Okay, welcome everyone. I'm going to do exercise 2C part 2 question 5 straight out of your textbook, which I have here. Right, we have to find the unknown a and b. They tell us that the function takes on this form and that the derivative is given to us 24x squared minus 24x plus 6. So let's start that. I'm going to show all the working out, but before we start, you can probably pick that the a value is 3 before you start. So why is that? It's because given some function with x to the power of n in it, we know that the derivative would be n x to the power of n minus 1. So if our n minus 1 term ends up being a 2, right, then our n term would have to be a 3. So we're suspecting that a equals 3 before we start. If you stop and think about this, right? Okay, but let's show all the working that you could do here. So the function that's supplied with the a and b, I can still find the derivative of that. It'll just have a's and b's in it. So we're using the chain rule. The a has to come out the front and we subtract 1 from the a. Now in class I've been calling that doing the outside. So remember I said the chain rule you can think of as outside inside or inside outside. Right? So a comes out the front, minus 1 from a, keep the inside the same. Now find the derivative of the inside. Derivative of 2x is 2. B is just a number, so derivative of a number is 0, and we're just left with 2a 2x minus b to the power of a minus 1, and we know what the derivative should be. Well, we know the derivative. They've told us that. I'm going to write it in. I'm going to factorize it. Okay, I can see every number here divides by 6. 4x squared minus 24x. Sorry, minus 4x. I'm factorizing by dividing everything by 6. And then 6 divided 6 is 1. Right, and again, I can see that the a should be 3, right? Although the form of these derivatives does look a bit different. This is 2x minus b, but it looks different to 4x squared minus 4, but pretty sure a is going to equal 3 here. We'll keep going though so the forms match up, and I'm now wondering, looking at this, have we got a perfect square? Right, because I'm seeing a squared number here and a squared number here. So with my knowledge of perfect squares, now this is a minus in the middle, so this type of perfect square, a minus b all squared. Right? So I think, well, that's a square number. What would the a term be? It would be the square root of 4x squared, 2x. What would the b term be? Just given that we'd need an a minus b perfect squares. The b term, I think, well, could be minus 1. If I took the square root of 1, right, then I could be thinking, well, you could have had a plus 1 or a minus 1 because minus 1 times minus 1 is positive 1. So that's fine. And then I would think, well, what would the 2ab term look like? be 2 times 2x times minus 1, which will equal minus 4x. So that all checks out. And we think, yep, that's a perfect square. So that can be factorized as follows: 2x minus 1 all squared. And now these match up quite nicely in their form. Right? So 2a equals 6, a minus 1 equals 2. And if we look on the inside of this derivative, 2x minus b matches up nicely with 2x minus 1. So that's going to be enough work to say, therefore, a equals 3, b equals 1, right? We've already got the minus here, minus b, so minus 1. And that's pretty much all there would need to be for this question. You could say, from inspection, you could write, therefore, 2a equals 6 and a minus 1 has to equal 2. But I think it would be okay to also just skip down to a equals 3. But that might be working out. That would be good to show in a test situation. All right, so I might leave that one there. I'm just thinking you could check it if you wanted to. You could say, all right, if my function really is 2x minus 1 cubed, well, we could expand this out. We could then take the derivative and just double check, do we really get 24x squared minus 24x plus 6? That would be a little bit of work, but if you had time and you're in a test situation, you could do that check and then be 100% sure that you've got the answer right.